Good morning, good morning, good morning. Welcome to day 2 of the Munition Clearance Week in Kiel. If you weren't here yesterday, my name is Terry Martin. I'm going to be leading some of the discussions here today and tomorrow. It's my great privilege and honor to be back again this year after having been here last year, 4 years ago. Yesterday, we had a very interesting day, lots of interesting panels straight through to the end, lots of new ideas. And it was really interesting to see how this whole space has developed over the past 4 years and how it's broadened out too, because as I mentioned yesterday at the opening, we're looking, of course, at munition clearance in all sorts of different contexts and the technologies that are important for that, and the whole policy environment, and the whole budgetary question: how do you pay for it? Who pays for it? Under what conditions? And now we're kind of broadening that out this year with the Munition Clearance Week. It's not just about munition, it's about critical infrastructure, which is very related in terms of the technical and scientific space. It's all happening in the water, things that are happening under the water, very important, on top of the water too. And so we're doing that as well. And we're also looking at what's happening in Ukraine, because that is shaping the environment, particularly in the Baltic, in a very big way. And also a lot of the technology that's being developed for this space is being pioneered to some degree in Ukraine with a lot of drone technology as well. And there are a lot of munitions being thrown into the waters there as well that have to be addressed. And so there's expertise that is needed there and expertise that is growing there, and all of that is represented here at this year's Kiel Munition Clearance Week. Anyway, without further ado, I'll just give you a quick overview of what we're doing this morning, and then we'll get underway. We first of all have a panel, which I'll introduce in just a moment, and then there's going to be a scientific plenary session right after that. And then we're going to have an early lunch today. So at 11:30, we're going to break for lunch, go over to the Wunderino exhibition hall, where there's a really interesting exhibition. Most of you, I presume, were over there yesterday as well. Fascinating stuff. And outside I should mention this again, outside in the parking lot, there is still, until 3 o'clock today, I think, the gray shark from Seascape. This is not a prototype. It's a huge, I think it's like 4 tons, operational, autonomous underwater vehicle that is worth taking a look at. They couldn't fit it into the hall. It was supposed to come into the hall. It would fit into the hall, but it was too heavy to get into the hall. So that's why it's outside, and that's why I'm drawing special attention to that, because you have to walk outside, walk around, or go down the steps, and you'll find it there in the hall. You can't miss it. Okay. So enough for that. I'll go ahead and introduce our panel. I'm really looking forward to this one. You'll see me on stage a lot today, by the way. I've got 4 panels, so I'm going to be up here for like 5 hours today, leading discussions. I'm very excited about that, but if you're, just kind of ignore me. I'm self-effacing anyway, and the attention should be on the other speakers. So allow me to introduce them, call them to I hope they're all here. I know I've seen 2 or 3 of them. The panel, by the way, it's Innovations in Munitions Clearance, Transforming the Value Chain with Advanced Technologies. So we're going to get into some technology here. Beginning with Arne Andreasen. If you would all please come up and just take a seat here on the stage. Kevin Hagan is with us as well. There's Kevin. Great. Okay, I hadn't seen you this morning. Good morning. Tommy Kaltofen and Armin Kessler. Gentlemen, great. You each have a microphone. You should find it on your seat or nearby. Let's see. I've got an extra one here. Okay. Well, enough of that. We'll just get started. Here you go. Oh, marvelous. So this is what's happening in the value chain. There's been a lot of talk, obviously, about value chains and supply chains and how they've changed in the context of, we'll say, political and economic events. But I mean, industries are changing. What we have in terms of being able to bring technology to the table and to bear in this space in terms of munition clearance, it's evolving all the time. It's being driven by lots of different factors, and I would love to have each of you talk to us about that. We're going to start with a set of presentations as we do, and then we'll get straight into the discussion. So Arne Andreasen, if you want to kick us off. Sorry, yeah. No, here. I'm sorry. Let me. That was here. Oh, perfect. That was my fault. Sorry about that.
Okay. Good morning, everyone. My name is Arne Andreasen. And I'm from UMag Solutions, the CEO of UMag Solutions. And my presentation today is about a new technology on the detection of UXO and naval mines. Because that's the first step in removing munitions, of course. And in UMag, we focus 100% on aerial drone magnetic solutions. So I'll be speaking about critical parameters for a good solution, and also the potential if you have a good solution, but also some of the barriers that we see of implementing these solutions for our munitions clearance processes. So just a short thing about UMag. We focus 100% on aerial drone magnetics, and up until a few years ago, that focus was 100% on land and naval mine and UXO detection. Now we're also moving into anti-submarine warfare and subsea surveillance applications. And we do everything in UMag except from building the drones. We partner up with drone companies, but we build and design the magnetometer payloads. We design and build the ground control stations to handle the payloads and handle the drone. And then we build all the software for the mission planning and also for data analysis and processing. So how does aerial drone magnetics works? Some of you may know it, but a lot of people are always asking the question, is that really possible? So you're basically having a drone that flies above a surface, so that could be above the land surface, above the sea surface, and then you are mapping the magnetic field. And if you're good, you get deviations, small deviations in the magnetic field from potential targets in an area. Whether those targets are real targets or if it's scrap metal, that's something that comes later in the analysis, of course. So in UMag, one of our main products is the V2MAG, which we have developed over the last 10 years. And it's a complete drone magnetic turnkey solution. And it's a dual-use product, so it's both for defense and commercial applications, and it's specifically designed for mine detection and UXO detection, both on land and at sea. And one of the things we've done with the V2MAG hardware is that we have now built a complete software package around it, so there's just one piece of software that does everything you need as an operator. So that software takes care of all the mission planning with the drone, and it takes care of the processing in real time. So you automatically generates map of magnetic anomalies in real time without you having to do anything. And then it also does the real-time target analysis, so giving you estimates of position, depth, and size of potential targets. So that's both targets in the water column, it's targets on the seabed, and it's targets below the seabed while we're flying above the sea surface. So that's something you can do in real time while the drone is still flying. So we have validated the V2MAG ourselves for quite some years now. So we actually started out as a survey company in 2018, and we have worked for all the main developers in Northern Europe, doing surveys in near coastal areas, and also some land surveys, and also some surveys in Ukraine. And we then launched the V2MAG as a product a couple of years ago, version 1, and now it's out as a version 2 with fully integrated UMag mission. And it's being used a lot in Ukraine by the Army and Navy for rivers and lakes and land areas and near coastal areas. And it's also been sold to several defenses in Europe now. So that was a little bit of a summary about what we do and what we are capable of doing in UMag. So going back to the specifications of how do we implement such technologies in munition clearance. And one of the most important things, the way I see it, is the total system noise level. That's what I would call it. So that's a combination of the sensor noise on the payload, it's a combination of the static noise, the static magnetic field, and also the dynamic magnetic field from electrical components, moving parts, all those things. All that combines gives you the total system noise level. And why is that important? It's important because in aerial drone magnetics, we can't get close to targets. We're flying above the sea surface. That also means that our sensor specs, our system specs needs to be much better than in marine magnetics. And that's because when you have a signal from a potential target, shown here on the graph, that let's say you have a 100 nanotesla signal at a half meters distance from a potential UXO, then already at 2.5 meters distance, you're down to 1 nanotesla. So you're really going down to 0 very, very fast. And at 60 meters distance, you're down to 0.01 nanotesla. So if you can take advantage of the last digits, so to speak, you can increase your detection range a lot. So in all, I would say, commercial available drone magnetic solutions, the noise levels are about 1 to 5 nanotesla in the final data. So that's when data have been heavily processed, filtered, and then you're getting down to noise levels around this level. Maybe a little bit lower, some systems maybe even higher. In the UMag, we have a noise level of a little bit less than 0.01 nanotesla peak to peak in our raw data, and a positional accuracy of 5 centimeters in all the data points, which means that we can really take advantage of that low noise level. Because as compared to other solutions, if you're on a land survey, we're not bound to be close to the targets in a grass field, for example. We can actually extend the survey area much better, even if you have bushes or low trees, still see the targets below those trees. Or if you have targets that are buried, we are not constricted to areas where those targets are very close to the surface or very big targets. We can look for very small targets, or we can go very deep. So if you have buried targets where you need to, for example, in offshore constructions, you need to drill for your power line, we can see those targets that are lying several meters below the surface. In offshore applications, of course, which is relevant here, again, we are not constricted to very shallow waters of, let's say, 2-3 meters if you're looking for 50 kilogram ferrous contents. We can go to beyond 10 meters, beyond 15 meters if you have good geology conditions, so a low magnetic background signal, for example. If you're looking for even bigger targets or naval mines, you can go even deeper. So that is a big advantage of having low noise data in the raw data, because we can work with the data in real time. We don't need to manipulate the data to get a nice signal. And that is one of the things that when you have a lot of noise in your data, you need to do heavy filtering. That generates a lot of potential false positives in your data from that filtering. So this is just an example of a data set. So the map you see here is actually a real-time map from the UMag. So clearly identified UXO. And you actually see also seabed geology, so the contrast between sand and clay, the drainage challenge, with just a few nanoteslas peak-to-peak signal in the entire area, basically. And because we have such a low noise level, we can actually work on the data and extract even more information without enhancing the noise. So we can completely remove the background geology and completely isolate the targets in that map without getting a lot of noise. And we are now down to a very small color scale in that map. So the potential in munition clearance as a first thing when you want to detect stuff, especially in areas where it's difficult to access, so coastal areas, nearshore areas, surf zones, but also harbor areas where you have potential naval mines, is just having a look at the bathymetry map for Northern Europe. I mean, basically there's a lot of areas out to 20-30 meters water depth where you could use drone magnetic solutions instead of bringing in ships and ground personnel and having to do a lot of trouble with weather and waves and bad data. So the benefits, the way I see it, if we should bring in a new technology to the munition clearance process, you have low operating expenses using aerodromagnetics. You have fast operations, 5 to 10 hectares per hour, because you're flying above the water. You have much less weather days. We are independent of waves. We are independent of tides. We're also quite independent of wind. So last week we did a survey in 13 to 15 meters per second wind, an offshore survey. It's easy to plan, very flexible to execute. You're not relying on a ship and ship time, personnel for the ship, and then you have minimum environmental impact. And if you have then on top of that a really low noise system with high accuracy data points, you get basically no false positives in your data, because everything you see on the map is actually coming from something that is magnetic. It's not an artifact of your processing. And then you increase your detection range to the extremes. And moreover, then in the following analysis, when you want to analyze for the targets, estimating the depth and the size, position, you get a much more reliable results because you can work on the raw data instead of working on the process data. And of course, you can get continuous data sets from land and out to 20, 25 meters water depth, depending on what you're looking for. And one of the main advantages is that you can adapt your survey design. So if you don't want to look for very small targets, you just increase your altitude of the drone or your line spacing, which is a bit more difficult in marine surveys, and then you can cover a much bigger area and don't find the very small targets if you're not looking for those small targets. And then you can have real-time actionable data, which is of course a benefit if you're in defense, but it's also a benefit for commercial operators that they can be on the beach or on the harbor pier and they can actually see the data in real time, that the data quality is good, and they can upload everything by the end of the day and say we're done. Barriers to putting this technology in, at least from our point of view, now we've been in the survey business for 7 years, we see there's a lot of conservatism in the survey industry. From major players, I'm sorry to say, but that's just how it is, because they have their boats, they have their ground personnel, so bringing in companies like us is a pain in the ass for them. And it's of course also due to the tender material that is being placed out by the wind developers, because the tender material is very conservative also, still focusing on traditional methods, traditional specs from marine magnetics, and that is not compatible with good drone magnetics. And then, unfortunately, also the market is dominated by low-cost, high-noise solutions that some companies tend to buy, and then they get disappointed by what they can find. For defense, some of the barriers we see is that there's definitely a lack of knowledge to what aerial drone magnetics can do. So mapping naval mines in the water column is something that comes as a big surprise to a lot of people in the naval EUD industry in the defense. And then of course they have a very long procurement phase, which is a problem because this is a very fast developing technology. So if you want to buy something today, but you don't get it before 3-4 years from now, the technology has changed completely. That's all for me. Thank you.
Thank you, Arne. So, Kevin.
I'm just going to stay here.
Fine with me.
So,
See, can we just make sure his microphone is going? Test. Just say test one. Test. So we're working on your microphone. Try it now.
closer now? There we go. Hey, good morning. So for those of you who aren't familiar with Oceaneering, we are one of the largest service providers to the international offshore oil and gas industry, with 12,000 employees working out of 70 operational bases on 6 continents. From our founding in 1964 as a commercial diving company, we've transitioned to where we now design, manufacture, and operate a fleet of 250 work-class remotely operated vehicles, or ROVs. In 2014, a conglomerate of Total Energies, Chevron, and Equinor challenged us to design an autonomous underwater vehicle, or AUV, that could improve on current pipeline inspections by completing missions in a single sortie, improving on obstacle avoidance, operating close to the seabed, combining and processing sensor data on board, and adjusting flight in situ.
Kevin, sorry, sorry to interrupt you. I just want to make sure your slides are being shown right now. I don't think they're on the screen.
I see the speaker notes.
Yeah.
There we go.
Okay, just popped up. This is great. Is this where you want to be?
That's where I want to be.
Perfect.
And increasing maneuverability, including the ability to quickly stop, hover, and maintain station. And good timing on the slide, because over the next 9 years, Oceaneering designed, extensively tested, and in September of 2023, fielded the Freedom AUV, which you see on the screen. Now, Freedom is not a concept. It's in use today. At over 2,300 kilos, it definitely falls into the large class of AUVs. But what makes Freedom different from most other AUVs are its 8 thrusters, which give it 6 degrees of freedom. And the untethered long-range capabilities of an AUV combined with the very high maneuverability of an ROV. This results in some unique ways to employ payloads, especially if you have more than one on board at a time. And Freedom has a lot of room. It not only has 2 cubic meters and 135 kilos of payload space, but it's payload agnostic with an open interface that allows you to accept, allows the vehicle to accept practically any third-party sensor or effector. And onboard autonomy has been designed to fuse sensor input and use the best sensor for a situation. Choose the best sensor for a situation and take autonomous action based on trigger conditions. So its autonomous behaviors include auto-docking and undocking from its launch and recovery cage, which is suspended in the water column and can charge the vehicle to 80% in 4 hours. So the first Freedom vehicle has completed almost 1,400 nautical miles of autonomous pipeline surveys and is scheduled to deploy to Angola for operations this summer. At the same time as navies are paying more and more attention to subsea and seabed warfare, the U.S. Navy recognized Freedom's dual-use potential and purchased a vehicle which will finish manufacturing hopefully in August of this year and then deliver. I'm sure we'll talk about it more during the discussion this morning, but I think Freedom is just one of the dual-use technologies we can bring to bear on the subsea munitions issues we're talking about this week in Kiel. Thanks.
Great, thank you very much. Yeah, my apologies for failing to introduce each of you properly in terms of what your actual functions are. I overlooked that. That was oversight in my part. I don't need to introduce the first 2 speakers properly anymore, but our next one, I'll just go ahead. Tommy Kaltofen is CEO of Atlas MARIDAN. The floor is yours.
Thanks for the chance on speaking here. The first one is
So we're working on getting your slides up there. A little bit of a ghost in the machine this morning, getting off. I hope you all enjoyed your networking session last night. I was there for part of it. I then attended a dinner and managed to get some sleep, but I think we're all kind of getting ourselves in gear here. We hope to have your slide on the screen in just a moment. Meanwhile, we'll check your microphones. Microphone's still working? Yeah.
mic check.
Sounds
Yes,
good.
Thank you. Yeah.
There we go.
As introduced, we are part of TKMS, 100% subsidy. MARIDAN is there for a long time, founded in 1992. We fielded the first AUVs, the M600s, to the Bears Marine South Africa already in 2001, and ever since we are maintaining, operating, and upgrading them for them. So if you ever gifted or own a diamond that's not paid with blood, there's a good chance that it was detected with one of our systems. The biggest recent step we've taken in our company was that we merged in early last year. We acquired a UXO survey company and hired a team of 10 high-end seismic specialists and provided them with an in-house spread of seismic gear. We are approximately 50 people paragraph 7, paragraph 20, all that's needed. But for those who know me longer, I'm the AOV guy. That's our CCAT systems. This was a survey executed in a dump site last summer. So we were operating a synthetic aperture sonar, 2.5 by 2.5 centimeter resolution across the full swath of approx 250 meter. And the first time ever, Mr. Greinert, that's for you. We have been towing magnetic systems ever since, either single-tow G882s or an in-house designed gradometer wing based on Sensors flux gates. And last season, we got our hands first time on the newly released Geometrics MFAM systems, which provide you 100 times a higher sample rate. And with these 1,000 hertz of sample rates, we are pretty convinced that we can run them directly mounted to the system. Arne introduced already system noise level. And so this eases up the operation massively, because in beforehand we had to tow them, reduces your endurance, and there's a relatively challenging thing when it comes to launch and recovery. What we've also done, this was a test earlier the year, we've integrated a micro-eel seismic streamer system to the AOV. So you can see the one down in the exhibition. So the problem with AOV demonstrations is different to Arne's business, that when our stuff works, you can't see anything. So there's a small thin line in the green line in the water. That's what it's about. And what it is meant for is that we tow the AOV, the sensor deep on the seabed, but the spark or the sound source, so to say, is deployed from the ship. With the sound source, it's a sparker system, so we ignite like 4,000 volts combined with 4,000 amps. So that's big boys game to give us the deep and precise ping we need to detect objects in the seabed. What we've further done with our long-term partners, also for the AOV services, is Fugro and Plan Blue. We integrated a hyperspectral imaging system. So this is not prototyping. We have already like 100 days in the back this year. We are cycling once around Italy to run transects on satellite-derived areas where Posidonia seagrass is expected. And the benefit of the hyperspectral imaging system is not just that we get clearer pictures, so we also add further information. So what the guys figure out is, for example, the ability if the plant is still doing photosynthesis. And why am I telling you that? We have also the standard Katria G882 survey spreads for UXO work. We're doing that. But I'm still of the opinion that this is not the end game. So people talking about AI, but I've once learned in school that for everything related to software, shit in, shit out is the rule. And we are of the opinion that if you really want to reduce your false alarm rates in the UXO detection, we have to add further data layer. So the magnetics is as good as it gets, but it's just the nanotesla value that is getting it out. With ultra high, and it's just stupid, but it is part of an ISO standard, the ultra high resolution seismics have the ability to provide you, in addition, the form factors and approximation of the sizes of the objects in the sediment. Same counts for the surface stuff. If we adjust, and this is what the provider promised me, at least it is untested, if we adjust the frequencies, the hyperspectral imaging system is working, you should be able to also detect dissolved chemicals in the water. And we're not just doing seismic on an AOV scale, we also have the spread for biggers. So this is our ultra high resolution spread, photos just taken 4 weeks ago in the Baltics. And when we are talking bigger, this is our biggie. This is 6 meter, 2 tons, has been in the hangar for some years, but we just recently decided that we get it back to the water and bring it in the new corporate. Thank you.
Thank you very much. Arne.
Side. My name is Arne Kessler from Fraunhofer ICT. I was asked to tell a little bit on the other side of the story, so what happens once we have a detection or a suspicious point. And therefore, I called it the challenges behind. So I'm from the south part of Germany. We are, okay. We are on the southern part of Germany, close to Karlsruhe situated. Here the look from our side across the Rhine Valley is France in behind. And you might wondering what we have to do with explosives. So we are the Explosive Institute within Fraunhofer. We're working since many years on explosion technologies. It's one of our core competencies to develop explosives. So as well, aging is always a topic. The first contact to old ammunition in the seas was the ROBIM project. This was the initial point to pick up these activities. In the meantime, we set up a competence website where the idea and the first content came from Klaus Böttcher, the ministry here at Schleswig-Holstein. And there's ongoing work within the Minesweeper project, shown on the bottom to fill up this competence website with further information and with ongoing research and engineering work. Right now, we are in the team of Seascape and are here in charge with the safety chain of the ammunition handling, and ongoing projects are Vortex and Minesweeper. There will be later a little bit more. So this is the area of Fraunhofer ICT contributions. There is a lot more across Fraunhofer, as we already heard yesterday. And it begins from the first touch through the wet storage, disassembling, the processing of the material flows, and at least the incineration. So a little more in detail. These are the perspective where we expect the challenges in the future. So we have now something on track, but this will not be the final solution for all the problems we already have, and these which arise with the recent political situations. So it's the extension for the ammunition capabilities of the process itself. There I see a challenge on the disassembling, scale up mainly, and to deal with all imaginable situations, a treatment of the material flows which arise, and not last the incineration itself. So what we have now is not suitable for the efforts we have to face. So what is the recent state? We have processable ammunition limited to safe to handle. So we pick everything up, bring it up above the waterline, and then follows the process. So the problem I see is the not negligible amount of higher risk conditions, and blast in place, as also mentioned various times, is not an option. So the challenge is beyond the immediate action program to design and implement an additional processing path. However it looks like it's also open for technical ideas. Our hypothesis in the Vortex project is a subsea unit which has an event detonation protection by the water column itself. If this is the solution, we will see, but the focus is to have a reduced tool set underwater for a pre-disassembling or bringing it into a safe state. So the ongoing activities we do there is that it's a Vortex work package, and within Minesweeper, we investigate as well for a decision support what is the intention and the work mechanism of everything which is submerged under the water methods. What is the intention? What is the function principle? How does it work? And how are they? How is sure what they really can achieve? And another activity within the European context is an alignment of the emission handling condition assessment and understanding, because we see there as well differences in the understanding of the UOD services and the person working on this topic. So what is disassembling? Yeah, disassembling, the recent state is many manual handling steps. I suppose this will not really change in the immediate action program. This is for a first approach. Is it okay? But it's not suitable for high throughput, and it's not acceptable for higher risk ammunition. So the challenge is to minimize and eliminate manual process steps. And ongoing activities are the technology open call for tender within the immediate action program. This is still running, so we will see what happens there. The incineration preparation process means the media stream treatment, not only portioning and bringing the portioned ammunition to a detonation furnace. It became as well clear that we have slurries, water explosive mixtures, yeah. Because we assume that water jet technique in any kind will be used, and there will arise as well from the sawing technologies, process water, cooling water. And yeah, it's new technology, and for this material flow as well, a solution is needed. Yeah. What are the challenges? We have widely fluctuating process water content in this media stream. The slurry properties we are already investigated within the robotics project. So we have sedimentation and foam building, which makes the process more difficult, and we have beside the explosive unpleasant varying substance mix. So soluble components as ammonium nitrate, ammonia. Metals from sawing from the shells. We have fillers like sand, wood, whatever was used in the Second World War, and cutting additives as well. So this is the ongoing main activity within Vortex, where a demonstrator is built up to come to an idea what is the need for a preparation, and what is the need for the thermal destruction oven for these slurries. Incineration itself, yeah, it is established technology, but the energy efficiency is not for this amount of explosives. We see the problem in the energy consumption, and as well for the additional material flow for the slurries. And the challenge will be to find a solution for the slurry combustion and the flue gas purification to meet the requirements of BIMSCH. And as well to find a balanced middle way between treatment, the technical effort there, and the combustion itself. This is as well a work package within the Vortex project. It's in the conceptual part to look on the energy efficiency. So we look on heat recovery, slurry combustion, and treatment is part of the demonstrator, and wet oxidation is as well considered for the liquid part as option, yeah, but as well in the conceptual part of the project. What is the overall need? We think it's necessary to need disassembling, treatment, and incineration as whole process. Yeah. To scale it up. The focus in the immediate action program so far is to bring a process on the sea which is based on existing proven technologies for many good reasons. Yeah, this is mandatory for the first approach. But the problem is that optimizations and multiplying of components will maybe a scale-up factor bring from 2 to 5, but this is not sufficient. The whole multiplying the whole process is expected to be uneconomical. So the upscale factor for one disposal facility should, on my point of view, be 20, better 50, to have a powerful solution to clear really a whole area. But this will mean a fully industrialized, largely automated process, and we have to close as well as possible the water loop for the process waters. Otherwise, we will burn a lot of water and waste a lot of energy. And our ongoing activity on this is beside the competence website to give research and engineering exchange a dialogue platform. This start next week, where is our annual conference in the Karlsruhe Exhibition Center. There we have a special session within the regular conference program. It will be chaired by me. A few colleagues will be there and will present the recent state. And as follow-up, it's planned to start a parallel conference format in next year beside this conference to focus especially on this incineration process, on research needed, on upscaling possibilities, technologies, and challenges which come up with them. So that's my talk. Thank you very much for your attention.
Thank you very much. So I'm going to try to distribute the extra microphone, and so each of you have one, I think. So, yeah, there are two. There's one under the table there, and here's one for you, sir. Great. So I think we have about a half an hour left to discuss. Well, we have more than that. We have 40 minutes left, so that gives us plenty of time to get into some of the questions that were raised in your presentations. We came up with some leading questions to help prepare this session, which each of you received, and I was really happy to see your presentations addressing some of these leading questions. What I find interesting in this particular panel, the composition, that we are mainly dealing with detection, I think, with three of you, and here we're looking very closely also at disposal when it comes to munitions, but we're looking also at dual-use technologies. These are technologies that can be used in different contexts. I'm going to get to your audience questions very quickly, but I'm just going to come back to one of the leading questions that we put through, and I'm going to ask each of you to reflect on that, and that is, when we're looking at this industry, specifically munition, not disposal, but detection, looking at the detection and then the disposal. It can be either one, but we're looking at munitions in this case rather than just surveilling or monitoring, say, pipeline monitoring. But in any case, we want to talk about the value chain and some of the technologies, emerging technologies that are coming through in the pipeline, because there is a lot going on the technological innovation side. So the question is, what would you say is the emerging technology in your area that is having the most profound impact on the trajectory in your particular field of expertise, what your company or your organization is doing? We'll start there at the far end and move in this direction.
10 years ago, I would have stated unmanned systems for sure. Nowadays, I would say it was Starlink, because now the guys on board can watch Netflix.
Sorry, I'm acoustically, I didn't quite get all of that. What?
Back in the days, I would have stated it was unmanned systems. Today, I would say it is Starlink, because the guys on board of my ships have better access to Netflix.
Okay.
No, but Starlink recently made a big difference. We just opened up our remote operation center. So the guys at home have now, or the office has now full access to everything what happens on board. So you can have the live data QC on site, and my CTO is always yelling on, get me the academics on board of my boats. They only cause problems. Okay, there's a bit of joke in the back, but yeah, if something goes wrong, you better have an electrician than a PhD geophysicist. In an ideal world, you better have both of them. But yeah, having full access to the offshore side is currently, I think, the biggest benefit of the last 1 or 2, 3 years.
So this would be, you mentioned Starlink, but that's a brand, right? So, but the technology behind it, we're talking communication satellites, essentially. And do you see, I mean, there's Starlink, but there's not only Starlink, right? Do you see any competition coming up in this, or is this going to be a proprietary sort of solution?
To my knowledge, up to now it is. So for good reasons, we would all be happy if we would have one.
Do you think there could be a European version of that? That's a big question, I know. You don't have to.
Someday, maybe.
One day, maybe.
But I'm not a specialist on it.
Okay, and unmanned was another thing I think you mentioned. Autonomous, I suppose. This would be the other key area in your estimation?
It's a different question, as mentioned.
But this is also it's not really a technology as such. It's a kind of a concept. I mean, there's technology that makes that possible, right?
Yeah, and the question is if it is emerging and when is something emerging. So as mentioned, we are operating our oldest systems for 25 years now. There's still systems coming and going. I wouldn't really describe it as a new technology anymore.
Right.
Because
exactly.
if you divide the whole process of having and operating an AUV or a complex underwater technology, you have your development phase. Then you have your accreditation certification phase. This is what by far costs most of the money. And then you have to get your experience with fielding the systems. So what we're not discussing anymore, any hiccups and any features in the systems. We are fighting on a daily basis on large offshore projects just to keep them going. Because if you're offshore, things go wrong, things bend, things break. So the logistics in the back is what I would describe as the third offset phase of fielding new technology. And that's where we are with the AOVs now.
And it's expensive operating out there, I must say, offshore to some degree, depending on what you're using. Anyway, Kevin, your thoughts?
Well, I'd have to agree that, right, the ability to communicate remotely has been a game changer. From Oceaneering's perspective, the large majority of our 250 ROVs are operated from 7 different onshore remote operations centers. So the ROV pilots work around the clock in shifts from Stavanger, Norway. We have OROC in Louisiana, OROC in Brazil, and the pilots can pick up operations of an ROV anywhere in the world. They found that this reduces their time underway and really reduces costs and allows the company to spread the load out over multiple different areas. Tommy mentioned autonomy as well, and I think that there's so much talk about artificial intelligence, and certainly it's come a long way, but it's still not at a point that it can be relied on. One of the issues is AI does great things, but when you test AI, or you have to be able to test it to understand why it made the decisions it made. And that's a real issue. There's no AI ranges in the world where you can send an AUV out, watch its behavior, and then bring it back and understand why it made some of the decisions it's made. And I think it'll be very important to develop that sort of testing regimen before we can fully trust in AI in the future.
I was wondering how long it would take us to get to AI, but it's interesting to hear the skepticism coming through on that as well. Which there's plenty of that, right? There's promise and concern. Good, Arne.
Yeah, I think from our point of view, one of the things we've seen that are really going fast is, of course, the drone technology. Because when we started doing surveys in 18, we could fly for about 10, 12 minutes with our payload, and now we fly for 35 minutes. And in a few months, one of our partners is coming with a drone that can fly for 50 minutes on batteries. So the battery technologies are going really, really fast in the drones. And also, when we started, it was only Chinese drones. There were no good European drones, but now, which is especially relevant also for the defense, there's a lot of good European drone providers. And of course, for us, it's just a tractor for pulling our payloads, but it makes a big difference that you can survey huge areas, and it's a reliable system that is carrying your very expensive payload. So for me, that's one of the main changes, and I agree. AI, that's a long way. Even though if you have good data, it's a long way because you need a lot of validation.
Good. I suspect we'll be getting some questions about that coming along too. Armin? I mean, you were on the research end of it, right?
Yes. Yes, and not on the survey part, of course. Yeah. So I see the most changes in the ammunition handling. Yeah, ammunition handling at the disassembling processes. So there are first approaches starting to come to a higher throughput, but there's not very much reached so far. Yeah. So automation is a standard technology since many years, and bringing this into this critical field of unclear dimensions of the munitions at unclear states. This is the challenge, and there are so far only approaches, but no proven technologies so far. So there I see the research need as well for the whole process part, because it's defined from the incineration. The needs, what is needed for disassembling. If you can throw the whole ammunition into the incineration, you have to do nothing. So the whole process, thinking new from the starting point, is still a challenge, I see.
Very good. Okay, we're going to open up the floor here to some more precise questions. We have a microphone that's standing there in this alley, this way right here, and we already see a couple of people approaching the microphone. So, yeah, sir, why don't you begin? Quickly identify yourself and put your question.
Yeah, good morning, everybody. Jens Greinert from Geomar, and Tommy already mentioned this once times. So it was, I think, 6 years ago where we introduced magnetometers on AUVs, and Tommy this time said, this is rubbish, this will never work, and now he does it himself. So this is, I think, quite a nice thing. So what the three of you just told, and what we also experienced, so we operate 6-kilometer deep diving AUV since 2008 at Geomar. So the vehicle itself is now working. The vehicle itself knows where it is, and it comes quite reliable back. I think 6-10 years ago, people were afraid, oh, I plunge something in the water, it does something, it is not coming back. This is done, we can do this. So the big next question is actually this autonomy. I think autonomous underwater vehicle is the wrong word that we have at the moment. They are automated. Automated underwater vehicles, you tell them what to do, they do it very, very reliably, but they're not autonomous. They start slowly to think. Yeah? So you have to put the intelligence or mission planning and some different examples of, if you find this, do that. Yeah, so that's what we have to put in now. I think that's the big scale. And my question to Tommy and the other three is, what is it that you think is most important? There's a little bit of obstacle avoidance here and there, but this is the one thing. There's more a security or safety feature, but make them smart to react on whatever they measure in the magnetics, whatever they see in the hydroacoustics, whatever they detect with a chemical sniffing device. Yeah. So Tommy, what would you think is the most important thing when you talk about autonomy? That's my question.
First, Jens, I have to correct you. I never said AUVs and magnetics is rubbish, because back in the days when we discussed, we were already using it. I complained on your integration method. Okay.
Okay, but even that worked.
This is where we still not agree. No, but your point is fully right. I would say on the first hand, it's none of them yet. because the whole AOV usage is still way behind its abilities. 10 years ago, we made a big investigation, visited navies and operators all around the world, and talked to them, and then an external consultant analyzed everything we were fact-finding. And he cooked 500 pages of paper down to trust. And reliability of systems being operated offshore is still the thing. Because the big contractors are sitting here, this is the thing to be proven, and proven does not mean in a demonstration. It has to be proven over hundreds and hundreds of days. Because if you are offshore, then it's not a matter of what your funky technology does on day 1 or day or 2. Because if you then had to have back 40, 50,000 euro ships because something bends and breaks, then it's pointless. And yeah, this whole, is it autonomy or is it automation? This discussion is as old as the systems itself. According to the, NASA standards, at least if they do obstacle avoidance, and this is in theory what they should do, but then they are defined as autonomous, so according to NASA standards. But we have these autonomy functions and these obstacle avoidance functions. But the reality of what my guys and my specialists out in the ships is doing, starting up the systems, override the autonomy and safety functions, leading to heavily scratches and bent marks, but they have enough spares. No, the reality is if you detect whatever sonar you use, a kind of a fish school or whatever, and your AOV aborts missions or does what the avoidance should do, then you have a lag in the data. And the surveyor doesn't want a lag in the data. So getting smarter, definitely, but I think it's still a matter of hardening and proving the systems are there yet.
Maybe one comment, Tommy. That's where I would disagree.
Thank you.
From Freedom's perspective, it's already proven that it can combine autonomy functions. So the reason the Equinor, Total, and Chevron conglomerate asked us to design it was so that it could be deployed and do autonomous functions without having a ship on station to watch over it. So it will use its multi-beam sonar to follow a pipeline, but at the same time it has a hydrocarbon sensor on board. So when it detects a potential leak, it can stop, hover, and use a stereoscopic camera that's on board to photograph that area and create a digital model and then bring that back to the surface. So we are showing that you can have more than just obstacle avoidance on a single vehicle.
Any other comments to that question? If not, we'll move on. Okay, yes, sir.
Yes, thank you. Good morning, everybody. My name is Sven Kuczynski. I'm an expert in marine conservation management and marine mammals, and I would like to raise your awareness to another aspect which comes with all these innovations you showed us, or with many of them. The fact is that underwater you can communicate by sound only, or mostly, and we increase the number of sound sources with all these technologies. And in a few years ago, the discussion with respect to mammals underwater focused on hearing impairment, but we now know that disturbance is at least as important to take care of. So my question is, when we get more and more data, acquire them with more and more technology, we put more and more sound sources into the water, will we bring solutions for today's marine problems like climate change, like munitions in the water, at the cost of disturbing the marine environment, which we want to save?
I would not. Am I on? Yeah. I wouldn't agree, because back in the days, you maybe actually use a big ship with a big hull-mounted multi-beam, And if you bring the sensors way lower to the seabed and operate an AUV instead, so especially for Kevin's applications in the big offshore oil and gas world, we're talking a 4-meter AUV compared with an 80-meter ship. And if you have to go across like 100, 200 meter with a multi-beam to get a high resolution in the side scan, I would assume, and I'm not a specialist, I would assume the noise is reduced by the application of AUVs compared to ships.
Okay. Any follow-up? Sorry.
Yeah, no, I would just say, I mean, also, of course, using aerial systems as much as you can, of course, doesn't impact the environment, but I agree that having better, smaller systems that instead of big ships is and less false positives also, so the less impact you have on the seabed improves things.
I mean, I know this is not your field of expertise, but you do work in research, and a lot of the colleagues that you work with,
Yeah, but not on noise of ships, and
okay.
so.
Yeah, it's unfortunate we don't have the expertise really sitting on the panel here today regarding the environmental impact of these technologies. But I'm sure that I should hope that they're built in also to the assessment of their impact. Yeah, this is a question I think we're going to have to explore in another context. So there's another gentleman standing. Thank you for the question, though. It's an absolutely legitimate question.
Good morning. My name is Dr. Lee Willett. I'm sorry to have missed the first couple of days of the event. And
You've only missed one. It's okay.
1 day. Thank you for the very interesting brief this morning. I'm interested in the subject of the dual use aspect. And actually, my reason for missing the day yesterday was because I was up in Helsinki running around with NATO and some USVs looking at what they were doing on seabed stuff. And the issue of the dual use option came up quite a lot. And I'm quite interested in that, in exploring the panel's views, because it was mentioned a couple of times. When you are talking about ASW or critical undersea infrastructure protection or MCM, you're talking about, I guess, 3 different functions, but increasingly in places like the Royal Navy, they're starting to refer to them collectively as things like underwater warfare. So I wondered I'd welcome the panel's views on what the benefits are of trying to think about these 3 things together now, given that the threat is so significant down there.
The 3 things being, again, just so we're all clear.
Anti-submarine warfare, MCM, and CUI.
For someone like me who's really not a specialist, I'd really appreciate it if you could just expand on those acronyms, just so keep
anti-submarine warfare, mine countermeasures, and critical undersea infrastructure protection. Those three things.
Just so we're all clear on that.
Thank you. Sorry about that. Sorry for being a bit. When I've been with NATO for a couple of days, it's very acronym heavy. Sorry.
I understand.
So, what are the overlaps in how you do this that make it possible? But also, what are the challenges that you see in trying to think about doing those 3 things with the same kind of vehicles at the same time? Thank you.
If I may comment on that first. I mean, the benefits, for example, from our point of view in magnetics, is that you can use the same technology for monitoring the critical infrastructure, for finding the mines in the water column or on the seabed, but also for finding the submarines. I mean, it's the same signal we're looking for. It's just different size of targets. And of course, submarines is often further out at sea than the mines we're looking for. But it's the same technology, so there's a big overlap in the knowledge that soldiers need to have, because once they learn how to use the system on finding mines, it's the same approach they're going to use for finding submarines, basically. Same the signal they're looking for. It's just different survey techniques, maybe a different drone that will carry the payload to fly further out and bigger surveys.
Yeah, and also wonder that this is sometimes sold as the reinventing of the wheel, that you can cross this border between civil and military application. Yes, for sure, you've seen who our shareholder is and what their core business is and what we do. So the CCAT systems we use for Fugros surveys is the same system as it's fielded with the Royal Navy. And especially for us, and it's not happening by accident. So the synergies, for example, you mentioned UXO and MCM, they are obvious, and we are already using the same sonar systems. For ASW, there is, sounds weird, but the physics and the technology behind an ASW system and the seismic system is pretty equal. So, and we are already working, especially as the civil subsidy of a military contractor, right in this field of profiting and shifting the benefits from one side to the other.
Yeah, as Tommy said, there's a huge overlap between military and civil use, and you see it a lot in the United States these days when the U.S. Navy and the U.S. military in general has been very happy to develop its own programs over decades and decades, but they're realizing currently that if they extend their reach and their view just a little further, there are some commercial systems that work just as well, if not better, than anything they can conceive of or develop themselves and are ready for use immediately, which also leads them towards looking at their or not just capability gaps, but capacity gaps. So we're seeing a lot in the US that the Department of Defense is paying for contractor-owned, contractor-operated capabilities so they can have sailors and soldiers doing other missions and allow a private industry to complete some other missions that it's more suited to, and it also allows militaries, especially if they have a very cumbersome acquisition process, to take advantage of new technologies immediately rather than waiting for those technologies to develop over that acquisition process.
Thank you very much. Just I think we'll move on because I see two more people there standing with questions. So, yes, sir.
Yeah. Thank you very much, and good morning, everybody. My name is Henning von Nordheim. I'm from the University of Rostock, and I'm teaching, managing, but also advising political levels in marine nature conservation questions. And that is why I'm particularly very interested in this issue. And please allow me first to congratulate this. What? Do you hear me enough? Yeah, I think this is fine. Please allow me to first congratulate, to hear what we heard today in progress and handling on the technology level, the issues of detecting, but also handling of ammunition. If I compare that with the meeting we had in 2007, which I, here in Kiel, arranged together with NABU, and we had the state of knowledge at that time, it's 18 years ago, admittedly, we were on a much lower level on things we had at hand to handle ammunition and to detect ammunition. But still, it's 18 years, and if you're critical, can you also say, in these 18 years, we have not made so much progress as we really would have needed, but we have it. And my questions now, first I would like to ask Arne, I just approach you with your first name. You mentioned in one of your slides, your technology does not deliver false positives, which is fine. May I turn it around? Does your technology also deliver false negatives? Or are there any ammunition components that you cannot detect with your technology, like lumps of TNT, for example? That is a question to you. And to Mr. Kessler, I have a question. The water cutting technology, we heard about it already in 2007. In Germany it was developed, and we thought, wow, this is done already. Nowadays, I would like to ask you, did I misunderstand your presentation that you're focusing on doing this technology, so to say, when you have the bomb or whatever at your hands on land, or do you also test it and practice it underwater? Underwater water cutting technology. These are my questions.
Thank you for this very precise question.
Thank you for your question. So to my knowledge, and we've done a lot of surveys, we've done a lot of testing and validation with Danish Navy, Dutch Navy, a lot of other navies, and also armies, and so far we haven't had any false positives in our data. Every time we see a signal, we know that there's something there. We find that there's something there. False negatives, of course, you can have false negatives if you design your survey wrong. So if you, that's what I was coming back to, you have this adaptable survey design thing with drones that, as compared to marine magnetics, where you're sort of stuck to your configuration. In drones, you can increase your line spacing, increase your altitude, and then of course you can get false negatives, right? You can miss targets that you wanted to look for. So that's part of our training, that we always train people to say, what are you actually looking for? What is your minimum threshold of ferrous content that you're looking for? And then we guide them, how should they design the survey. And then, of course, we are mainly looking for objects that has a ferrous content. We do see aluminum mines if you're close to them, but it's mainly ferrous objects that we are looking for. Everything that has a magnetic contrast, basically. But even contrast between clay and sand, we see. So even just a very small magnetic component gives us a signal. But there are things we don't see.
Okay. That very briefly, because there is someone else waiting with a question as well.
Just my concrete question was lumps of TNT when the shell has dissolved completely.
Yeah, lumps of TNT. I think it depends if it's in the soil, if it's in the seabed. So the contrast between the TNT and the seabed. If the seabed has a slight magnetism from magnetic grains, then potentially we could see it. But that depends also on the depth, because then the signal contrast is low.
Thank you. Kevin, there's a question, I think, to you or not, or sorry, to Arne.
Yeah, okay, so yes, water cutting technologies is established technology for many years, especially for the EOD services to cut out igniters for bombs in land findings, of course. Yeah, but it's only for the cutting purpose, yeah, so far. And this is this work is not done so far, yeah, from our side. We will investigate it next year. It's in the conceptual part of the work package robotics. And we intend to have a complete tool set for the platform solution, so an above the waterline cutting. And what will happen for the higher risk ammunition is not so clear so far, yeah. It might be a completely underwater solution, but then we have a contamination problem. So my idea is a subsea unit with water cutting as the only tool below the waterline. But you have the contaminated water then, and you have as well abrasive in the material flow, which you have to handle in the further process, in the disposal process. So. We will investigate what is on the market. Yeah, this is work planned for the first quarter of next year, and what is not available on the market so far is water flushing technology to flush out explosive or cut. Yeah, maybe cutting could be as well a solution, but flushing out the mass of the secondary charge out of the shells. So everybody you ask tells this is not problem. Yeah, but if you ask for showing us, then it becomes quiet. Yeah, so you have high pressure water technologies for cleaning pipelines, for cleaning vessels. Yeah, there are special nozzles available, but they are not suitable for flushing out explosives, and for cutting is established technology. Could I answer your question so far?
Thank you very much. Excellent. So, one more question.
Good morning, Anja Dreves, TenneT. Let's draw up on a very realistic future scenario. Imagine TenneT is changing all of their specifications and requirements, and all geophysical survey in the future for the intertidal area, for dry falling, and for the nearshore will be airborne and uncrewed, so AUV and USV only. So that's the way we would like to go out for tendering. So what do you see right now as obstacles within the permitting process and in the permitting conditions, what might be a hiccup in such an operation and need to be removed up front?
complex question. Anyone want to answer?
Yeah, but they know what I'm talking about.
Yeah. No, we've had this discussion a little bit already, Anja. Specs on noise level, from our point of view, is definitely something that needs to be changed. It needs to be changed from the marine magnetics to something that fits drone magnetics, because you're further away. But also the way you define gaps in data from marine specifications, those gaps are not applicable one-to-one on drone magnetics. So that's
that is our part. But I want to know what you want the authorities to remove when you speak about flight restriction, for example, that you need to fly in the line of sight, and for example need to have a ponton or a rib or everything every 2 kilometers to have a look at your drone. This is what I call a hiccup and something what is just unnecessary in my opinion.
Yeah, but regulations are definitely a showstopper in several countries in Europe. So having that beyond visual line of sight or beyond 500 meters limitations that some countries have, that is definitely a showstopper. So we should be allowed to fly as far out as we trust the drone ourselves, basically. And that's many kilometers.
This sounds like a super interesting discussion. I can imagine that we could do a whole section on that. Unfortunately, we only have about 4 minutes left. There's one more question standing in line. Sir, if you could keep it brief, and we'll try to wrap this up.
Yeah, my name is Ad van Riel still from UXO, the Netherlands. I've got a question to the three gentlemen. Basically, we always need a validation on our detection systems. Have you validated your systems? And if so, is that validation information available? And the second question is, if you are in a project, do you also execute a SIT trial to check and see what the results are in the specific area?
Thank you. I don't know if we'll get all of this answered in 4 minutes, but...
Yes, for sure we do.
So the first answer, yes, we do all of that?
Yeah, we always do SIT when we do surveys. We don't do that many surveys anymore. We sell the equipment instead, but we always do a SIT. And we have a lot of reports on validation, so you can just get them.
That was the second part of it. Is that information available?
Yeah, and from Oceaneering's perspective, we're a sensor agnostic company, so the sensors would all be validated by the third-party providers. Oceaneering doesn't develop any sensors of its own.
Good. Great. I'm just going to wrap this up now because we do need to move on to the next session. But I have two quick questions, really quick. One is going to be, first of all, to Tommy. You mentioned ultra high resolution seismic as if that could be the silver bullet that you're looking for. So you put a lot of confidence on that particular point. Do you see that as a technology that could end up being super promising in this area of detection?
I invested 3.7 million into that out of a 50 people company.
Could you
how convinced could I be?
How much did you invest in that? Sorry,
we invested 3.7 million just in the seismic spread in a 50 people company. What do you think? How convinced I am?
So that's an indication of confidence. Okay, I'll take that. Good. The other question is that I have very quickly is for Arne, because Arne, you're putting a lot of you're coming from an aerial solution versus an underwater solution, and you're suggesting that the industry of surveying and detection is rather conservative, and that's a barrier to you. I'm just wondering how you three gentlemen working in we've got underwater and above water. How do you see that? Do you think there's potential very quickly for this to be shifting more towards aerial stuff if we maybe get rid of some of the regulatory barriers we just referred to? Do you think that will?
I don't think their technology can shift to air, but I think there's a lot of overlap in what we do because their systems work really well also on deeper waters, and we can go out to a certain depth. So then you have a complete coverage of what you need to do.
So, your drones only stay airborne for a certain amount of time right now, and you work mainly within 30 meters of depth, is my understanding. So that's a very
Yeah, I think persistence is part of it. When you can have a system operating at full ocean depth for 6 months at a time, I think there's something to be said about that.
The the militaries would describe it an MDO approach, multi-domain operation. So it isn't necessarily an either-or. It's like with all survey gear, you start your project with the toolbox talk and decide on which toy to play with today.
I like that. Both and, not either or. Very good. Thank you all very much, and thank you all for your questions and listening. Thank you.